Okay. Okay. Thank you for that musical introduction. So yeah, my name is Ed Walsh. I work for NASA at the Johnson Space Center, and in the last 5 or 6 years of my career, I've spent working on the Orion program. So by a quick show of hands, who here has heard of the Orion program? Okay, not too bad. I always like to see how our public outreach department is doing. Now, if you didn't raise your hand, no worries. By the time I'm done talking, you're all going to be experts on the Orion program. So in a nutshell, what Orion is it's really NASA's next manned spacecraft that will take humans beyond lower Earth orbit. And so I'm going to give you a little background on our program and explain what the hardware is and what it does. I'm going to share some recent accomplishments with you and tell you what we're planning for the future. Now, you may know that we at NASA love to use our acronyms, and that's very true. So I'm going to be very careful and try and spell out everything today, but these are terms and acronyms I use at work every day, so if I slip up and forget to spell something out, let me know at the end and I'll go into a little more detail on that. So to kick things off, I've got a quick 3-minute video that's going to show you what an Orion manned mission might look like coming up in the future, so let's watch that together. This is a test flight of the launch abort system, not the parachute system. So this crew module is going to be making a big splash in the Atlantic Ocean. And it'll be up to our public affairs department to explain that to the public and say, no, that was not a mistake, trust us. It was all according to plan. Anyway, next chart. Okay, so this is a little animation that shows you the flight plan, I guess, for Exploration Mission 1, which again is that first integrated test flight between Orion and the Space Launch System rocket. So it starts out by doing a couple orbits around the Earth to check out the Orion systems. And then we do what's called a translunar injection burn, where you leave the Earth's orbit and start getting an orbit around the Moon. We'll spend a few weeks around the Moon checking out Orion's systems in its natural environment, I guess, or its real environment it's designed for. Again, in deep space, we're looking at things like its deep space maneuvering, functioning in that harsh radiation environment that I described earlier. And then on the way back, we'll be able to test out the heat shield and the parachute system again. The test flight we did in 2014, we did test the heat shield, but on this mission, you're coming back much faster, so it's going to be a real test of the heat shield. Next chart. And now I've got some pictures to show of our recent accomplishments. This is the crew module that will go on that flight that we were just looking at. So I always like this picture because it makes it look like it's hovering here, but it's not hovering. It's being suspended from above, and the shiny coating on the bottom is covering the heat shield. Up a little bit higher, you can see some of the circular coverings that are here that are covering the crew module's reaction control system thrusters. Again, the crew module has the ability to rotate in all 3 axes because when you're coming back and re-entering the Earth's atmosphere, you want to make sure you're positioned just perfectly so the heat shield does its job. And this is in an assembly station at the Kennedy Space Center. Next chart. Okay, here's some more of the crew module hardware for that same flight. Starting in the upper right, that's the crew module again. It's sitting in this white structure that we call the bird cage. This is a test article where I'm testing the pressure vessel of the crew module, make sure it's ready to go. The panels there in the middle and the bottom of the screen are called back shell panels, and they're used as part of the thermal protection system. So between those panels and the heat shield, that's what really protects the crew and the spacecraft during re-entry. And again, this is in Florida at the Kennedy Space Center. Next chart. Okay, I've got a few charts that show you some of our big test articles. Now, to evaluate our engineering designs, we do a lot of analysis and a lot of testing. And most of the tests can be really small scale of like individual wire harnesses or individual electronics boxes. But sometimes you have to do a really big test, and this is one of those. This is called the structural test article. It's in Denver at Lockheed's facilities. And here we're evaluating the structure of the Orion stack as a whole. Now, it might look a little different than the previous diagrams of Orion that I showed you, but you can see the launch abort system on top again. Under that, these dark brown or dark gold panels here are called fairings, and underneath those are the crew module and the service module. The fairing's job is to protect the crew module and the service module on the way to orbit. So after a few minutes, these things, there's 3 of them. They're about 2 stories tall and 20 feet wide, something like that. They fall away and their job is done. But that just explains a little bit why it looks different than the earlier charts. So again, we're evaluating the Orion structure here. So aspects that aren't structural don't need to be tested. So for example, during a real mission, the crew would have their fancy computers and displays. We don't have that in here because we don't need it. We have mass simulators, so it's the same size and the same weight as those, but to save money, we don't need them for our structural test. That's just one way we try and cut costs. Next chart. This is another big test article. This time we're testing the propulsion system for the service module. And again, all the propulsion components you see here are flight-like and match the flight hardware, but other aspects don't need to be. This is called the propulsion qualification module. So I can point out some of the features here. This is a high-pressure helium tank. And then it's a little hard to see, but there's 4 large propulsion tanks here in the middle. We use hydrazine and an oxidizer as our fuel source. And so the way the prop system works is the high-pressure helium pushes your hydrazine, your oxidizer, through tubing down to your thrusters. You can see some of them here on the bottom in red. And the fuel, it's called a hypergolic fuel. All that means is when you combine these 2 chemicals, they automatically ignite. You don't need an ignition source. So it's dangerous, but it makes it for a simple design that works in space. This picture is taken from the White Sands test facility in New Mexico. And we do this kind of testing out there because it's rocket fuel, and when you're doing a test with real rocket fuel, you want to be out in the middle of nowhere. Next chart. This is another test article. It's called the Integrated Test Lab. This is again in Denver at Lockheed's facility. In this case, this is a test article that's checking out Orion's electronics and wiring and avionics systems. So again, from that standpoint, this matches the flight hardware very well, but you can see that there's no heat shield, there's no back shells covering it because we don't need it for a test like this. Next chart. Okay, so those are pictures of some of the test articles. Now we have some flight hardware. This is a crew module for that ascent abort video that we just watched. Again, it's not as fancy and flight-like as a real crew module. There's no windows, there's no real crew computers because we really don't need it. It's basically the dummy that the launch abort system is going to be saving during that test. And it's good that we're saving money because again, this thing is going to slam into the ocean and we don't want to mess up something fancy. This picture is taken at the Johnson Space Center a few months ago, but this crew module is now down in Florida getting ready for that flight. Next chart. And then here's the corresponding launch abort system hardware that's in Florida. On the lower right here, you can see the nose cone. And then in the middle, the 3 motors that I was talking about. This is the abort motor that pulls the crew module away. And then these dots right here are part of the attitude control motor. It can fire thrusters from any side, however it needs to orient the crew module. And then the jettison module, the thrust from that comes out right here and pulls it away. But I like this picture because it gives you an idea of the size of these things. You can see there's a guy working on it over here. Next chart. Okay, so going on to exploration mission 2 now. And as a reminder, this is going to be the first mission with people on it. So this is the structure that humans will be in when we go back to the moon orbit for the first time since Apollo. So you can see on the right, there's the bird cage again, because every crew module has to go through that same structural testing in the bird cage. And then on the left, I was going to point out a few features to you guys. These are the windows. You might be wondering why we paint the crew module this lovely avocado green color. That's a corrosion protecting coating. And then if you look closely here, you can see this grid pattern here, and you might be wondering why we do that. That's to save weight. We've seen in our structural analysis that you get the most bang for your buck as far as the structural support from the little fins of the ribs that make that grid pattern. So you can machine out all those individual pockets and save a lot of weight. And when it comes to spacecraft, getting as light as possible is important. And we always like to say Orion's always on a diet. We're always looking for ways to save weight. Next chart. And then again, this is some more exploration mission 2 hardware. This is the raw structure of the service module. This is what it looks like when it comes from Italy. So it's just a raw structure. They're in the process now of installing wire harnesses and tubing and some of the smaller components. Later on, they'll be putting in larger things like the prop tanks. Two of them go in these large circular holes here. And you can imagine on a spacecraft, everything's very, very tightly packed. So when you put it in the prop tank, you lose all kinds of access behind it. So the biggest components come in near the end of the assembly sequence. So this is, again, being assembled by Airbus in Bremen, Germany. Next chart. So hopefully you kept up with me. I know that I showed you a lot of hardware and talked about a lot of different flights and terminology. But if you're interested in learning more about Orion and following us day to day, we have a really good social media presence. So please look us up and follow us on there. And thank you. That's my last chart. I'm happy to try and answer any questions if anybody has any questions. Okay.
I have a question.
Okay.
Surprising, I would have a question, but how does one get into something like this? We know you went to U of H, graduated in 96. You're just a couple years older than me and have a much more successful career than your own. But how did you get into it? I mean, you probably had the love for this, but where does one go, hey, NASA, look at my resume, you know, and get accepted into something like this?
Yeah. So yeah, I went to U of H and I majored in mechanical engineering. And as you might guess, to have a technical degree like that is, I wouldn't say it's required, but it's very, very important to have a hard science or a math type of background. But yeah, so when I graduated, Lockheed was hiring, and so I remember I had two job offers, one from Lockheed and one from this company, I can't remember what they're called, that made seals for the petrochemical industry. And I mean, I was happy to get any offer, but to work at NASA, that's always been a dream of mine because I feel like I'm not an engineer's engineer. I like to have subject matter that interests me and helps me stay engaged. And so, yeah, I spent my career working for different contractors at JSC and eventually got hired on by NASA. So I guess math and science is the number one thing. And then, of course, networking. Back when I graduated, the internet was very small and it was very hard to get, you know, there's no job boards or anything like that. You guys have it easy compared to how we had it, if you ask me. Networking, LinkedIn is super important too.
Yeah.
So those two things I think would be the top two.
You're probably like me. I had to, this is going to date myself, but for college, I used a typewriter on my applications. Did you?
I can't remember that far back.
Oh, you feel like you're the only old one.